Let's start first with our sum from n equals 0 to infinity of n factorial over 3 to the n. So for this, we're going to use a ratio test, and we're going to look at the limit as n approaches infinity, the absolute value of a of n plus 1 and a sub n. So for us, a sub n plus 1 is just n plus 1 factorial over 3 to the n plus 1. And we're going to divide that by a sub n, which is n factorial over 3 to the n. Now, there's a good way to do this. Basically, you multiply these two over multiply these two. Okay, so we have n plus 1 factorial times 3 to the n over, now we're going to multiply these two, and it's good to line them up properly. So we'll put the n factorial here, 3 to the n plus 1 here. Now n plus 1 factorial is n plus 1 times n factorial. So I can write this as n plus 1 times n factorial. And now the n factorials are going to cancel. 3 to the n and 3 to the n plus 1. Well, 3 to the n plus 1 has an extra factor of 3, so that's going to go away. And so what I'm left with is n plus 1 over 3. And we're going to take the limit as n approaches infinity. We don't care about the absolute value here because n is going to be positive. And so because n is positive, everything else will be positive. And we get that the limit is infinity. So because the limit is greater than 1, this will diverge by the ratio test. Okay, now let's look at the next example. We have the sum from n equals 1 to infinity, n times 6/5 to the n. So again, we're going to use the ratio test. So we're going to look at the n plus first term. So for every n, we're going to plug in n plus 1. And then we're going to divide that by the nth term. Now, I can't really simplify n plus 1 over n, so I'm going to leave that as it is. But I could simplify 6/5 to the n plus 1 and 6/5 to the n. Notice the one with the n plus 1 exponent has an extra factor of 6/5. So this simplifies to 6/5 times n plus 1 over n. Now, we know that, well, I guess what we could do at this point is multiply everything by 1 over n. Okay. So we'll pull out the 6/5. And you want to distribute the 1 over n to both the n and the 1. And in the denominator, n times 1 over n is just 1. So I'm not going to bother running that. And so this limit goes to 1, but we have to multiply by 6/5. So it's 6/5 times 1, which is 6/5, and this is greater than 1. So by the ratio test, this diverges. Now let's look at another example. We have a sum from n equals 1 to infinity, negative 1 to the n, times 2 to the n over n factorial. So we're going to look at the n plus first term. And this one we're going to need the absolute value because we're dealing with a negative 1 to the n power. So this will be alternating between positive and negative. Okay, so we'll have negative 1 to the n plus first, 2 to the n plus first, n plus 1 factorial. And then it's going to be all over the nth term. So again, we're going to have a situation where you're multiplying the top and the bottom. So that will just be -1 to the n plus 1 times 2 to the n plus 1 times n factorial over, now you're going to combine these two. So you're going to put them all, you're going to multiply these basically. And the order, you want to be careful. You want to make sure that they line up. So we're going to have -1 to the n first, and then 2 to the n, and then finally n plus 1 factorial. So the -1 to the n plus first will cancel, and we'll be left with a -1. 2 to the n plus 1 and 2 to the n will have a factor of 2. And then n factorial over n plus 1 factorial will just have n plus 1 left over. So now it's -1 times 2, which is -2 over n plus 1. And so we're going to be taking the limit of this, and we're looking at the absolute value, which clearly this is 0. And it doesn't matter if you take the absolute value or not, it's still going to be 0. Okay, so now because this is less than 1, this is going to converge by the ratio test. Okay, next, we have the sum from n equals 0 to infinity of e to the n over n factorial. So again, we're going to use the ratio test. So we'll look at the n plus first term, and then we're going to divide that by the nth term. So we're going to multiply the first and the last. So it'll be e to the n plus 1 times n factorial. And then we're just going to multiply these two. And again, line it up properly. So you should put e to the n first, and then n plus 1 factorial. The e to the n plus 1 will cancel out with e to the n, and we'll be left with power of e. And then n factorial and n plus 1 factorial will give us an n plus 1. So that's just e over n plus 1. We don't need an absolute value, so we're just going to look at n approaching infinity. And this is 0. The limit is 0, which means this converges by the ratio test. Let's do one more. So we have the sum from n equals 0 to infinity of 6 to the n over n plus 1 to the n. Let's use the ratio test again. So we'll look at the n plus first term. So here we have to be careful because not only is there an n over here, but also the exponent. So this n in the parentheses, we'll replace it with n plus 1. But because we'll add another 1, that turns into n plus 2. Then the exponent is n plus 1. That's going to be over the nth term. Now we're going to multiply the top and the bottom. So it'll be 6 to the n plus 1 times n plus 1 to the n. And that's going to divide it by these two multiplied. And we're going to line it up properly. So put 6 to the n first, and then n plus 2 to the n plus 1 power. Now this is going to cancel. We're going to be left with a power of 6. And this one's going to be a little tricky. So what we should do, well, here I'm going to rewrite this. And I'm going to split this up into n plus 2 over n plus 2 to the n. So now they have the same exponent. And so I can bring it all in the same exponent. So that would just be n plus 1 over n plus 2 to the n. And at this point, we're going to keep simplifying to get something nicer, because it doesn't seem like we could get a good number, or good limit from this. Okay, so actually, okay, let's do this. So we know that this limit right here, as n approaches infinity, is going to be 0. But what happens over here? So, well, I can do this. I can rewrite n plus 1 as n plus 2 minus 1. So that's still the same thing. And now I'm going to break it up into two fractions. So n plus 2 will be the numerator, and then we're going to subtract it with 1 in the numerator. So this is really 6 times n plus 2, 6 over n plus 2 times 1 minus 1 over n plus 2 to the n. So we know that this is going to be, so now actually let's take the limit. So I can find the limit of the products, or the product of the limits, like this. And this is going to be 0. Now this is going to be e to the negative 1 power. So the limit is 0, which means that this converges by the ratio test.